Hey everyone, welcome to Singularity Computers, Client Build 18, Part 5. This is the final part of the build log, so we're going to take a good detailed look at the finished product, and then I'm going to cover the test results. And I can't wait to see the temperature results for this build, because there are 3 custom Singularity Computers water blocks in this system. 2 on the motherboard, 1 on the RAID card, and this is a first for me. This is the first time I've ever built water blocks, so obviously I'm really excited to see how they are going to perform. It was so exciting when I was filling the loops for the first time and just watching the coolant flowing through these water blocks after the amazing amount of time that went into the development, the engineering, the CAD, the prototyping, and the manufacturing. So it's very exciting. I mean, it's definitely another whole level compared to just normal modding. I mean, it's what I'd bare minimum call extreme modding. And that also goes for these custom cables. For this build, the custom cables took 5 times longer than anything else, although that doesn't include the water block development time, which took even longer. But the custom cables always take a considerable amount of time. They're about a quarter of the build if you're just doing custom cables for the core components, 24-pin, PCIe, EPS, and ATX. Now, if you are modifying the existing cables, it's about half the amount of time compared to building them from the ground up. I always build all of my custom cables from the ground up. There are only 6 strands of wire in this computer that are not custom, and it's the cables for the power and reset buttons, which I easily could have made custom just so that I could say that everything was custom. It would have taken me like an extra 15 minutes. Also, these SATA data cables in this build are not custom, but still they've been customized. I mean, they're still sleeved, and a lot of time still goes into that, but everything else has been custom built from the ground up, customized to length. If I do, well, there's 21 radiator and case fans in this build. So imagine doing all of those fan extension cables. Well, if I lay all of those cables into position when I'm doing my cable management, and I find that one of them is 1 inch longer, or usually it's a few of them, well, I modify the cable, I cut it down exactly to the length that it needs to be, because I don't want any excess cables at all. I want there to be the absolute least amount of cable mess possible, and for those cables to look as beautiful as they can, even if they're going to be completely out of sight. Each wire strand is laid next to the other. If I have one cable twisted around the other, I will pull it all the way back out to the source to untwist it so that I can lay them in there again perfectly. So if you consider that, generally about a quarter of the amount of time just goes into doing the custom cables for the core components, and then you add all of the other cables for, well, everything else, right down to the lighting, you can easily double the amount of time again. Then if you add an Aquero, and generally the builds that you're using Aqueros in have a lot more fans, well, you can double the amount of time again. And then if you add all of the extras that have gone into this system, the 20 hard drives and the 4 SSDs, the hot swap bays in this build, well, then you can double the amount of time again, and it compounds. I mean, just to give you an idea, we used every single port on the AX1500i, and even after that, even after we used all of the connections on the AX1500, I was still having to think about how I was going to get more power, and we actually had to do quite a lot of soldering. We had to solder the cables, all of the SATA cables for the SSDs, for the hot swap bays. We had to split them out to try to get enough power. I also designed my systems very much for the future. So I'm thinking about the client, about future upgrades, maintenance. I don't just build the systems the way that suits me. And a good example of this with the custom cables is I build the cables into layers. Now, sometimes you don't have to think about this, but in a build like this, with the amount of custom cables that we have here, I had to think about 3 different layers. So the lowest layer is, well, I've put into the lowest layer the components that are inherent to this build that are the least likely to be changed. And it's really the cooling system if you think about it, because the components that are going to be upgraded in a few years, the motherboard, CPU, GPUs, memory, SSDs, hard drives, all of that needs to be easier to access. But the water cooling system is going to last for a very long time through multiple upgrades into this system. And so that's what I mean by inherent for the build. And all of that can go into the lowest layer. And the lowest layer, it's all about accessibility. It's the one that's hardest to get to, that you have to pull apart the most of the build to actually access. And you would have seen that as I was building the system. Most of the cables for the lowest layer actually go behind the hard drive bays, and they all go to the Aquero. So it's the cooling system. The next layer is the storage, the hard drives, and the SSDs, the hot swap bays. And then the top layer is the cables for the core components. So, that is just a little bit of the thinking that goes into my designs. It's time to take a look at the water cooling loops, and I'm going to cover each individual fitting that I've used. So as always, Bits Power Black Sparkle fittings, 16mm hardline compression fittings, and EK 16mm PETG tube. I've done the same thing for both of the drainage systems. I've used a Q fitting, a mini D-plug, and a mini valve. Then going into the first motherboard water block, I've used a 90-degree dual rotary fitting. Coming out, I've used a 20mm extension fitting, a 90-degree single rotary, a 10mm extension, another 90-degree single rotary, and then one of the Bits Power telescopic fittings. And this fitting can actually extend to almost twice its length. And this is the largest size. There are 3 of these now. They're a great fitting, but it worked out perfectly because I only needed to extend it by, as you can see, about 1mm. And this is far better than using tube because the tube would have been on angles. So I'm really happy with the way this turned out. 90-degree singles going in and out of the CPU water block. And then I've used a little trick here. This is a 90-degree triple rotary fitting. So the extra rotation allows you to tighten the fitting from both sides. 90-degree singles going in and out of the MOSFET water block, and then going into the radiator at the top, a 90-degree single and a 30mm extension. Coming back out, a 30mm extension, 90-degree single rotary, 90-degree dual rotary, and then going between the radiators, and I've done the same thing at the top and bottom. I've used tube, a 90-degree dual, another 90-degree single with another 30mm extension, 30mm extension, and 90-degree single on this side. And then going back into the top of the reservoir, I have a 90-degree dual rotary with a through panel fitting, and then on the other side, just directly a hardline compression fitting, then a 90-degree single going back into the top of the res. For the GPU loop, I've done exactly the same thing for the drainage system, as you can see. Going into the top of the graphics cards, I have a 90-degree dual rotary, which I've used to gain the offset, then a 90-degree single, and between the graphics cards, I've used 1-inch D-plugs, and these are pretty much the original quick disconnect. They've been around for a very long time, but they're a great fitting to use between the graphics cards because they create a whole lot of strength, and they're also just such a simple push fitting. They work great. And, they look good in certain builds. I think it fits this build a lot better because it's a practical workstation system, whereas tube is a lot more elegant. Going in and out of the RAID card, we have 90-degree single rotary fittings. Coming out, we have a 90-degree dual as well. Going into the radiator, we have just a straight hardline compression. Coming out, a 30mm extension, 90-degree single, 90-degree dual. Then we have a length of tube, then the same thing. And then coming out of the lower radiator on this side, we have a 30mm extension and a 90-degree single rotary. Now for this length of tube, I had no choice but to use a fitting on the bend just once in the entire build because I only have 500mm lengths of tube, and this length was over a meter. So this is an interesting 90-degree fitting. It has no rotary or any kind of fitting, just a female thread on each side, so it's a great fitting to use for this. 90-degree single going into the through panel fitting. Coming out the other side, I've used another telescopic fitting, the largest size, going into a 90-degree single rotary back into the top of the reservoir. Lighting is something I haven't actually talked about in quite some time. I haven't actually covered the topic how to properly use lighting in your build. And whenever I haven't covered a topic for a while, I think about the builds that I've seen since then, and I think have people actually taken on board what I've been saying. I mean, it's not as if everyone is going to see my videos, but still, and always people seem to take it on board. The information gets out there, and it's great to see, because I remember people just used to flood their builds with light. It's what I'd see every time. But what I've been saying for a very long time is that to use lighting properly, you have to have contrast from light to dark. Without that contrast, you just don't have the definition. You light up the main areas, the highlights of your build, the main features, and you leave the other parts that you don't really care about so much in darkness, generally speaking. Now, the customer requested something for this build which I'd normally say no to, which is combining UV light with normal light, and it's obvious why you should normally avoid that. But in this build, with the placement of the lighting and the layout of the components, also the size of the case really helps. I have managed to position the lighting in such a way where the white light doesn't really have an impact on the UV light. So we're still getting an excellent UV effect. So, we have the clear UV blue coolant reacting nicely to the UV light, and the white light lighting up the black coolant. It's worked out very well. The lighting I've used is from Darkside. I almost always use Darkside lighting in my builds. I have 3 30cm LED strips, 2 UV LED strips at the top, and 1 white LED strip at the bottom. You can pick these up on the Singularity Computers store, along with a vast range of different cable options to power them. So the thermal design in this build, for the radiators it's obvious. As always, I've worked with convection. I'm drawing cold air in the bottom, exhausting the hot air at the top. I have 3 case fans for the front compartment, creating positive pressure inside of the case and drawing in some more cold air for the main compartment. And these are actually dust filtered, but the intakes for the radiator fans on the bottom of the case, I haven't dust filtered. And this is because obviously I build a lot of systems. So I get a very good chance to test everything, components, configurations, and do a constant survey of what actually works. And for dust filters, I've used all of the different dust filters out there, and I find that no matter what you do, they're just not effective enough. Dust still gets in, so I'm not really into dust filters anymore at all. I would rather not use them, actually. With the impact that they have on the aesthetics and performance, I think it's better to go without. Unless somebody comes up with an improved solution for dust filters. So the fans on the hot swap bays are drawing air in from the front, cold air, through the hard drives, and then there's obviously also the fan on the power supply exhausting the air out the back. It's now time for the performance and temperature results. The big moment, you're going to see how the Singularity Computers water blocks perform, and also what I've managed to achieve with the overclocks for this build. As always, I never push the overclocks too far, but I'm still very happy with the performance gains that I've managed to achieve. I mean, this is an incredible config, so it is to be expected. And it was a lot of fun overclocking this system. It has heaps more headroom. The client is no doubt going to be able to push it a lot further. that sums up this build. There were so many details surrounding this build that I never actually managed to get to. I would love to have shown you how I set up the Aquero with the fan curves. The fans don't even cut in until the coolant temperature reaches 25 degrees Celsius. So when you power on, you don't even know the system is on yet. And then as the coolant starts to heat a little, the fans cut in. You know, just so many fine details like that, which, you know, really make this system the ultimate, take it to the next level. Such a perfect combination. The workstation focus, you know, I really enjoyed setting the bar higher for Singularity computers with the custom water blocks. The amount of custom cables in this build, so much fun. But we have so much more coming up as always, and some builds that I'm really looking forward to. Next year is going to be an amazing year for Singularity computers. But that sums up this video. Thanks for watching, and remember that none of this would be possible without our patrons.